It has been almost a year that we all live in COVID-19 situation, and this coronavirus outbreak has major impact on businesses, especially for the retail sector. The new normal and people behavior change. For example, to avoid human contact, they do online shopping instead of visiting physical store, and this directly affects daily operations of the retailers. However, one of the reasons that some people rarely go back buying goods from the offline store is because the experience in the store are not convincing enough comparing with online shops. There are a lot of promotions and ways to get discount codes, while in offline shop there are more like grab and go. The question is how they can take people back to their physical store and how they can conduct scenario planning even better. So there is a room where computer vision technology can help the retail sector understand the offline customer behavior and plan the business strategy more effectively. And ISL has been researched in AI for years, and one of our projects, ISL Retail Vision, got funding by investors to develop the solution and apply it on real business cases. So the Retail Vision now is named as Manavis, which is under Baxter Company, and I would like to hand it over to Avanish to talk about different challenges that we face in building our product features and how we tackle them from the technical point of view.
So basically, I'll be talking about some of the key features available in our Manavis solution. So, like two key features we have in our solution is density analysis and user analysis. So we realized early on that in order to tackle these requirements, density analysis, what you had to do was we had to detect a person, like, or people in the frame. So for this, what we did was we utilized some of the state-of-the-art deep learning architectures, and we custom trained models for this particular use case, so retail stores. And we utilized like transfer learning to take a base model and then custom train our models based on the architectures. But in order to achieve our goals, detecting a person was not enough, right? So we also had people across the camera frame. So in order to do that, what we did was we implemented custom trackers based on Kalman filters. And the custom tracker also took into consideration the velocity of the person. So the direction as well as displace as well as the movement of the person itself. Could you move on to the next slide? So as you can see in this one, basically we were able to track the person across the frame. Now, based on what we developed, we were able to generate analytics like heat maps, density analysis, stuff like that. So we realized that there are certain areas in a retail store that customers focus on. So what we wanted to do was we wanted to provide deeper knowledge to the clients. So we wanted to answer a few questions like how long was the person standing in front of a shelf? Are they buying anything from that particular shelf? If they are, what were the products they bought, or were there any other products they were interested in and then they did not like buy it? These were the insights that we were able to present to our clients. So based on this one, we started realizing that there were like a few spots that the customers were like really focusing on. So we wanted to see like what was happening there. So we wanted to also answer questions like how long the person was in that particular spot. Were they interested in any products from that shelf? Did they buy the product? Stuff like that. So we came up with a new feature in our product lineup, basically a smart shelf. So once a potential customer came into the view of the shelf, we wanted to track the person as well as the actions taken by that person. So basically, to achieve this one, we trained a custom model that could not only detect a person, but also their actions, as well as classify the product that they were holding in their hands. So once we were able to tackle the technical side here, we were able to come up with insights like dwell time, so how long the person was standing in front of the shelf, product interaction time, like how long they were holding the product, what did they do with that product, did they put it back into the shelf or did they put it in their basket, things like those. So utilizing these computer vision related features, we were also able to provide them with O2O feature, so offline to online feature. So in the video here that's playing, if you can see, once the potential customer holds a product, we can show like details of that product on a screen. So we can provide like detailed information of the product, reviews of the product, or anything else that the client wants to show to the potential customer to increase sales of that product. So these were some of the features in our retail solution. So recently we had this unique opportunity to work with an event organizer where the environment was quite different to what we were used to in terms of like deploying the product in retail stores. So this one, instead of retail store, what we had to do was we had to deploy part of our solution in a big hall where cameras were installed at a height of 10 meters. So our products we knew would work with retail stores where the camera was like at 2 meters height maybe, or like 1.5 meters height, but we were not sure whether it would work at a height of 10 meters. So during the testing phase, we realized that our product was not suitable for like this scenario. So we had a few solutions we could try it out. So first one was basically trying to train the model for this particular use case, um, which was usable in a real-time scenario. But because we were mostly focusing on density analysis for this particular event, we did not need to deploy any trackers here. So we had this opportunity to try a more robust deep learning based architectures that was that could detect people like better than the one we used in retail stores here. So as you can see, like based on what we were able to develop, we could still generate like density analysis for the event organizers here. So based on this one, they could see like which stalls or like which area of that event was people mostly focused on here. So yeah, so these were some of the aspects or like features of our solution. Now I would like to hand it back to Wave to conclude the presentation.
So in conclusion, Nanovic Smart Retail Solution can handle both the small area scale like retail store and the bigger scale like the convention hall. As we develop the model by ourselves, so it can be customized to the customer requirement. At this point, they can get the inside data and use it to maximize their business value in both sales and strategic planning. So if anyone has questions, feel free to ask.
Okay, thank you. Okay, we got one question, actually a couple of questions. So let's start off with who raised first? Mustafi, would you like to go first?
Okay, so I have a question. So suppose you have new products coming in. How long does it usually take to train that product? I mean, for example, for retail vision, you suppose you deploy it at a store and they have new products coming in. For example, they might have sunglasses or something else. Usually, how long would it take to train that the image of that product?
So basically, in this one, if we already have all the product lineup for that particular retail store, we can actually train all of them like in advance. So we don't really need to train a new model for a different product. So we just have to know like what products were like kept in that shelf basically. But if there's a new product lineup that comes in that we have not seen before, then we will need to train that. So like we just have to train them, but usually like should be like 3-4 days probably.
So by lineup, you mean like a completely different type of product, right? So,
Yeah, something new that the system does not know, basically.
okay.
So if there's a new product coming in, then we have to train that. But chances are like but the benefit is like if the shop has a few products they're going to sell, then we can actually train products beforehand, even before they are deployed in that particular shelf.
Got it. Thank you.
Great. Ken, I'm gonna give the floor to one of our guests first. Okay, so one of our guests raised his hand. Pantep, Kun Pantep, can um, you can go ahead and ask.
Hi, my name is Pantep. I am a Jantap friend. I'm working in the airport industrial. I work in the airport for 2002. So I would like to know that for this solution, how can we apply to the airport business? Because in the airport we have so many areas that we have a passenger move from one area to another area, like in the check-in counter, in the immigration, or even in the delivery area, or the restaurant area, or some even the lounge. So, what do you think? How can we apply this to the airport?
I think business-wise, Wave might be able to answer this better. But basically, apart from what we showed today, we also do demographics classification for the customers, for the people we see in the frame. So basically, in terms of like airport scenario, I think our product basically would be able to like provide you with details such as like how many people are in a particular place at that particular moment, demographics, like what age group they are, or like gender, race, things like those. But I think because like the analytics part of our product depends on client by client basis, the best way would be like to have talks with the clients to see their requirements and then come up with different analytics for that particular scenario, I think.
And okay,
Yeah.
if we okay, if we not cover the COVID situation, the airport will be quite busy, right? And then for the scenario, how uh, uh, for your application, how fast it can be processed? In case that can we check whether the passenger when they go to the check-in counter, maybe someday the airline staff they take around 15 minutes per passenger. Can we like predict that how long or how much passenger will pass from one point to another point, like after they check in, how long when they go to the check-in, how long they will go to the uh, immigration or passenger visit point.
So if I'm understanding this correctly, you want to know like how long a passenger took from traveling from point A to point B, right?
Yes, and can your application do the real time?
Yes. So as I explained in the presentation, basically we work with like various kinds of architectures, deep learning architectures. So the first one that we used for the retail store, it's a real-time architecture. So we are able to process the incoming frames in real time and then provide the insights to clients in real time. But the second scenario that we talked about in a hall setting, basically they did not require any real-time features. So we were able to use a more robust model basically for that one. But we do work with like various different kinds of architectures that does processing in real time as well as in batch, basically.
Okay, maybe we should have more talk on this.
Yeah.
Yes.
I'll let you have more talks on this, but I think from my understanding, the next step for this project is actually on something called multi-camera tracking, and that might actually answer Pantep's question just now in tracking people across the entire facility.
Yeah.
And Kian, would you still have a question? I think we can still take up 1 more minute.
Yes, I have just one more question. Like, the product that we take out the shelf will be shown on the screen. Then, when I take 2 products at the same time, like, will that be any error or what the screen will show?
So that depends. I think that one technically it works. So we are able to detect, like, if the person is holding 2 products in both the hands, then we are able to detect both of them separately. So this one depends on the business model. I think how this product the client wants to show. Do they want to do like half and half screen? So that one depends on I think business model of the client.
Yeah, so it's possible, right?
Yes.
Okay, thank you.